Alright, Mathletics kids. We finished on number 7 of measures 2. So here is number 8. So if you look at how many dollars are in a roll of quarters, if a roll contains 40 quarters, well, I'm going to create a proportion. I'm going to say that there are 40 quarters. I know there are 4 quarters and $1. My quarters cross each other out. So 40 divided by 4 equals $10. To find the difference, then I'm going to go ahead and I'm going to say that I know there are 4 quarts for number 9. There are 4 quarts in a gallon. So there's a couple ways to do this. One is that I can set it up as 3 gallons, 2 quarts, 1 gallon, 3 quarts. I'm just going to subtract. I know there are 4 quarts in a gallon, so I need to borrow from this. I would add 4 to this, so I go here. So 6 minus 3 is 3 quarts. 2 minus 1 is 1. 1 gallon, 3 quarts. Karen estimates that her household does all this good stuff. Good for them. So if there are 9,000 households, and there are 26 days, and there are 6 cubic feet per household, then we can go ahead and we can do that math. And if I do that, 9,000 times 26 times 6. What that gets us, though, is 1,404,123 cubic feet of garbage or recycling per year. Now, it's asking for it to be in cubic yards and in scientific notation. So in order to do that, I need to set up a proportion, and so I'm going to move this over a little bit. So I have I know that there are 3 feet in 1 yard, 3 feet in 1 yard, 3 feet in 1 yard. I have the 3 here because I've got cubed. It's feet times feet times feet. And I cross out all 3 of those. Yards times yards times yards gets me yards cubed. When I go through and I solve that, that gets me 52,000 yards cubed. In order to move it to scientific notation, then my decimal is here. How many places I move left? So 1, 2, 3, 4 is the exponent, so 10 to the 4th. 5.2 times 10 to the 4th. Scientific notation always just wants one number in front of the decimal, and everything else is behind it. Because these are all zeros, I don't need to include them in this right here. And so it's 5.2 times 10 to the 4th. If we go on to our next one, sequence, series, and all that jazz. Find the sum of everything here. Well, my pattern is plus 12, so one way to do it would be just to add 12 to everything. That totally works great. Another option that I could do is that I could take 180, and I'm going to add the first term, which is 36, and that gives me 216. So I see that this guy plus this guy equals 216. Now I'm going to see that pattern is going to be continuing as we go forward. Now, what I'm going to do is I'm going to say, well, what's the difference between those two? So I have 180 minus 36, which gives me some number, and we'll get there in a moment. I'm going to divide by, well, we're adding 12s each time, and so how many 12s am I adding is going to be there. And then we're going to have we're going to, excuse me as I try to read my own handwriting. Then we're going to add one over here. And what that's going to tell me is that I have 13 numbers. 13 times that this pattern of 36 plus 180 is found. So then I go over here and I say, well, if I have 216, multiply how many times that 36 plus 180, or in this case 48 plus 168 would equal that as well. Okay, that's going to be the total, but because that's for every two numbers, I divide by 2, and I see that this sum is going to be 1,404. On to number 2, the 10 top students in the Mathletics competition. Shake hands to other students, shake hands, blah, 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 blah. Alright, so what we're going to do is, essentially we have 9 plus 8 plus 7 handshakes that are happening and taking place all the way down until we get to 1. So what we could do is just 9 times 10, and we're going to divide by 2, it's 2 people within a handshake, and that gets me 45. For number 3, in the sequence, what's the 86th term? Well, I see I'm adding by 4 here, so we could just make a nice little chart here, and so I know that this is plus 4, so I'm going to make a chart, and I'm going to say this is term number 1, so term 1 is 4, term 2 is 8, term 3 is 12, and so forth. And so if I think about doing that, I'm going to say that if there are 86 terms, and each time I'm adding 4, I can go 86 times 4, which is going to give me the 344th term. If you chose to create a linear expression, you get the same answer as well, a little bit more work. For number 4, which day of the week will it be 2007 days from Monday? The thing that you have to know and remember is that there are 7 days in a week. And so if we're talking about 2007 days, if I divide that by 7, that'll give me the number of weeks I get. So I have 286 weeks with a remainder of 5, which means that from Monday I need to count 5 more days, and I'm going to get Saturday as my answer. And for number 5, what's the next number in the sequence? Well, I should be seeing my pattern is I'm dividing by 2, dividing by 3, dividing by 4, dividing by 5, which means that my next one is dividing by 6. 1/10 divided by 6 is the same thing as 1/10 times 1/6, which gives me an answer of 1/60th. For the Fibonacci sequence of 1, 1, 2, 3, 5, 8, 13, each term afterwards the sum of the 2 previous terms. So we see that 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus, and so forth. Which one of the 10 digits is the last to appear in the units position of a number in the Fibonacci sequence? So if I continue with this, starts with the ones, which one of the 10 digits is the last to appear in the units position of a number in the Fibonacci sequence? Let's talk about this one in class, because I don't know if I have enough room. So we'll go on number 6. 10 tennis balls are stacked to make a pyramid. 1 ball is in the top layer. Each layer after that is a square, so the second layer is 4 balls, the third layer is 9 balls, and so forth. So how many tennis balls would be contained in a pyramid that has 10 layers? So if I've got 10 layers, okay, because it's a square, then I really can just worry about the sides and don't need to worry about number of balls. So I think I see in the first one, it's 1 ball. It's a 1 by 1 or a 1 squared. In the second layer, there are 4 balls, which means it's a 2 by 2, which is going to be 2 squared. So forth, the third, and so forth. I'm going to keep doing this until I get to 10 squared. If I square all these numbers first, following PEMDAS, and then add them all up, I'm going to get 385 balls within that pyramid. Alright, Jackie put some dimes in a pile. Then she doubled the number of dimes, took 24 away. She doubled the number of dimes, took 24 away. 2 more times, had no more dimes left in the pile. How many dimes were in the pile when Jackie started her game? Well, all I'm doing is I'm going to work my way out. I'm going to create an equation to work it out. So, she had some dimes in the pile. She doubled them. So 2 dimes, doubled the dimes, and took away 24. Next, I'm going to keep on reading. So she's doubling this whole quantity, and then it's taking away 24. And then it happens one more time. This is where brackets really come in. She doubles the entire quantity right here, and then takes away 24. And if I go ahead and it tells me that the entire thing right here leaves me with 0 dimes. Well, then I got to start figuring out, how do I solve this? What we're going to do is we're going to start with that distributive property, those rainbows. And so 2 times 2d is 4d minus 2 times 24 is 48. That's in here. I still have this minus 24 minus 24. And that's right there. So I keep going with this, and so now I've got 4d minus 48 minus 24, and I'm multiplying this inside quantity by this right here. So that's gonna give me some more rainbows and goodness. That's not going to give me 8d minus 96 minus 48 minus 24. If I go through and start doing some PEMDAS, I can start combining some things here. And so I see that this is 8d, and that's equal to 0 still. So I have 8d. If I combine all those terms, because I'm subtracting all, I get 168 equals 0. Now I'm going to want to solve for the number of dimes, so I'm going to add 168. What I do to one side, I must also do the other. So now I've got 8d is equal to 168. I want to undo this multiplication, so I'm going to divide by 8. Divide by 8. And I see that the number of dimes that I have is equal to 168 divided by 8, which is equal to 21. For number 9, 5 people are standing in the line for coffee. CC is standing directly behind Teresa. 2 people between CC and Kate. Kate is standing somewhere between Jason, but somewhere in front of David. Which of the 5 friends is 4th in line? Well, I'm just going to go ahead and I'm going to give me 5 lines, 5 positions they could stand. Alright? As I go through, I'm just going to start guessing and checking some things. I can go ahead and say, well, can I try this? Does that work? No, it doesn't work, because I see that CC has to be behind Teresa, and there are 2 people between CC and Kate. This gives me, right here we're good, but Kate is standing somewhere behind Jason, so Kate has to be on the other side here. Instead, as I go through and I do that, then I see that I can get this order right here, and the 5 friends, the next in line is Teresa. For number 10, I'm going to go ahead and I'm going to make a Venn diagram that talks about for the 2 things. So I've got geometry over here and I've got algebra over here. I know there are 29 over here and there are 16 over here and there are 39 that fit inside of there. So in order to solve this, I'm going to say, well, there are, how I got 29, how I got 16, sorry I didn't talk about that. 29 is the number of geometry students, which is 68, minus 39, the number that both take. That gives me a 29. Over here I got this by doing 55 minus 39, will give me 16. Again, they both take this, so they can't count for both sections. So I do that and I add up now all of these 3 students, or 3 groups, and I get 84 total students. So the average of 4 numbers is 12 and large numbers remove. Okay, so because I'm talking average, I know. I think you have a good day. Time to go. Because I'm talking average, I know that I added a bunch of numbers and then divided by something, divided by 4 to get this 12. So to undo that and to find out what the total sum of those numbers was, I'm going to take 12 times 4, which gives me 48. Now I'm removing a number, which means I really have 3 numbers. With an average of 9, I'm going to go 3 times 9, because the sum of those numbers was 27. Now, to find out what number was removed, I'm going to subtract 48 minus 27, and I see that it should be 21 was removed. The mean is the same thing as the average, so the mean of a set of 12 numbers is 30, so I'm going to go 12 times 30, which gives me 360. And the mean of another set of 18 is 50, so I'm going to go 18 times 50, which gives me 900. The reason, again, I'm doing this is that if I know what the sums of them are, I can combine these 2 and then divide by the total numbers that I have. So when I do that, I combine these 2, then I get 1,260 divided by, there are 30 numbers over here, and I see that the mean of the new set is 42. What's the positive difference between the range and the median of the following sets? Well, in order to find the range and the median, I need to order my numbers from smallest to largest. So I redo that, say 1, 2, 3, 5, 6, 7, 8, 8, 8. The range is the difference between the highest and the lowest, so 8 minus 1 equals 7. My range is 7. The median is the middle number of the set. Because I have 9 numbers, I have a middle number that is 6. And so my median equals 6. And I want to know the positive difference between that. So I'm going to say 7 minus 6 gives me 1. For number 4, I realize that you might not have done much of these yet, which is fine. We're going to draw a box-Muster plot. A box-Muster plot looks like this. That's what every one of them will look like. These might be shifted, but they look more or less the same way. Now, we're going to go ahead and label. I'm going to say that with this set of numbers, I'm going to want to put it in order. It already is in order from smallest to largest. That's fantastic. All right. Over here, I will have an outlier at a 20. because that is super far off compared to the data set. Next, it asked me to find the mean. Well, to find the mean, I'm going to add all the numbers up, and I'm going to divide by how many numbers there are. Going through and doing that, I see that my mean is 69. Find my median. I'm just trying to find the middle number. So I go check this off. My middle number is going to be there at 70. My mode, the most often, 70 is on there 3 times. That's my mode. The range, difference between the highest and the lowest, 90 minus 20 is also 70. The inner quartile range. Now, what the inner quartile is I'm going to look at my set of numbers. So I'm going to rewrite it here. Okay, now I know I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers, which means I have 5 over here, 5 over here. This is where I get my median from. The average of 70 and 70 is still 70. To find my inner quartile range, I'm going to now split these in half or we'll go over here. I'll split these in half to find my first quartile. Well, there's 5 numbers. So the middle number is that guy. This is my quartile 1. Do you see me over here? 5 numbers. This is my middle guy. This is quartile 3. This guy right here is quartile 2. The median is quartile 2. To find the interquartile range, I'm going to subtract 64 from 80. 80 minus 64 gives me an answer of 16. For F, any outliers? Well, this guy is obviously my outlier over here. And what's my next one? And quartiles of this data. Well, we found those already. Quartile 1, quartile 2, which is really 70, and quartile 3 is 80. I know that this 20 is an outlier because of how far out it is in comparison to the interquartile range. So if a number is 1.5 times greater than the interquartile range, it's an outlier. My interquartile range was 16, so I would go 16 times 1.5, which gives me 24. If my outlier is 24 less than my smallest number, then it is going to be an outlier. 60 minus 24 gives me 36, therefore this is an outlier. Now my box and whisker plot, I should have this on a number line. There's 20, here is 60, and then these would be lined up, so forth on that. Alright, I will finish the rest of this at another